Howdy, once again on Cryptodome. I haven't read this yet, but it sounds very interesting. Warm liquid spewing from Oregon seafloor comes from Cascadia Fault, could offer clues to earthquake hazards. Geothermal activity. Mountain water. Yeah. Sounds crazy, maybe. But this looks like an underwater mountain to me. This sonar image of the Pythias oasis. Yeah, you know the oases in the desert. There is water, that's why they are oases. Shows bubbles rising from the seafloor about 2/3 of a mile deep and 50 miles off Newport, Oregon. These bubbles are a byproduct of a unique site where warm, chemically distinct fluid gushes from the seafloor. Researchers believe this fluid comes directly from the Cascadia megathrust zone or plate boundary and helps control stress build up between the two plates. It doesn't help, it's just a part of the process. The field of plate tectonics is not that old, and scientists continue to learn the details of earthquake-producing geologic faults. The faults are not creating the quakes. It's just part of the mechanism. Earth grows. That's why we have those cracks all over the place. The Cascadia subduction zone, so I don't think there's any subduction zones anywhere. The eerily quiet offshore fault that threatens to unleash a magnitude 9 earthquake in the Pacific Northwest still holds many mysteries. A study led by the University of Washington discovered seeps of warm, chemically distinct liquid shooting up from the seafloor about 50 miles of Newport, Oregon. The paper, published on January 25th in Science Advances, describes the unique underwater spring. Yeah, mountain water. The researchers named Pythias Oasis. Observations suggest the spring is sourced from water 2.5 miles beneath the seafloor at the plate boundary, regulating stress of the offshore fault. Yeah, like we have all those lakes and streams coming from the mountains, they are regulating the stress of the mountain. The team made the discovery during the weather-related delay for a cruise aboard the RV Thomas G. Thompson. The ship's sonar showed unexpected plumes of bubbles about 3/4 of a mile beneath the surface. Further exploration using an underwater robot revealed the bubbles were just a minor component of warm, chemically distinct fluid gushing from the sea floor sediment. When do they tell what it is? They explored that in that direction, and what they saw was not just methane bubbles, but water coming out of the seafloor like a fire hose. That's something that I've never seen, and to my knowledge has not been observed before, said co-author Evan Solomon, a UW associate professor of oceanography who studies seafloor geology. The feature was discovered by first author Brandon Phillip, who did the work as a UW graduate student and now works as a White House policy advisor. Observations from later cruises show the fluid leaving the seafloor is 9 degrees warmer than the surrounding seawater. Calculations suggest the fluid is coming straight from the Cascadian megathrust, where temperatures are estimated 150 to 250 degrees Celsius. I will put a link below, you can check out the video. I just want to get that through. The new seeps aren't related to geologic activity at the nearby seafloor observatory that the cruise was heading toward, Salomon said. Aren't related. Instead, they occur near vertical faults that cross-hatch the massive Cascadian subduction zone. These strike-slip faults were sections of ocean crusts and sediment slide past each other. Exist because the ocean plate hits the continental plate at an angle, placing stress on the overlay continental plate. Maybe not. Loss of fluid from the offshore megathrust interface through these drag-slip faults is important because it lowers the fluid pressure between the sediment particles and hence increases the friction between the ocean and continental plates. Maybe I just have to make it like this. Maybe we got rid of it. Yes. Where we have been. The megathrust fault zone is like an air hockey table, Solomon said. If the fluid pressure is high, it's like the air is turned on, meaning there is less friction and the two plates can slip. If the fluid pressure is low, the two plates will lock. That's when stress can build up. The fluid released from the fault zone is like leaking lubricant, Solomon said. That's bad news for earthquake hazards. Less lubricant means stress can build to create a damaging quake. Or if there's just all of a sudden coming much more out, there's more fluid. It's not good too, I think. Fluctuations in the circuitry. This is the first known site of this kind, Solomon said. Similar fluid seep sites may exist nearby, he added, though they are hard to detect from the ocean's surface. A significant fluid leak off central Oregon could explain why the northern portion of the Cascadian subduction zone off the coast of Washington is believed to be more strongly locked or coupled than the southern section of the coast of Oregon. Pythias oasis provides a rare window into processes acting deep in the seafloor, and its chemistry suggests that this fluid comes from near the plate boundary, said co-author Deborah Kelly, a UW professor of oceanography. This suggests that the nearby faults regulate fluid pressures and megathrust slip behavior along the central Cascadian subduction zone. Solomon just returned from an expedition to monitor sub-seafloor fluids off the northeast coast of New Zealand. Yeah, there might be one or two volcanoes there as well. The Hikurangi subduction zone is similar to the Cascadia subduction zone, but generates more frequent smaller earthquakes that make it easier to study. But it has a different sub-seafloor structure, meaning it's unlikely to have fluid seeps like those discovered in the new study, Solomon said. Yeah, so they didn't tell us what it is, so now let's check out if we can watch this. Here is the document. Maybe it's behind institutional walls. We would have to pay for it, no access or access through your institution. Does it say anywhere? Accept all cookies. Research article. This might mean that it is open access. Introduction, yeah, it might be open access. But this would take too much time. Pythias oasis. Yeah. Geologic setting. Yeah, I don't know if there's any point to make this through. Much like other subduction zones that exhibit a variable. Despite the intensity of sampling, little has yet been recovered that informs on fluid rock reactions occurring from 150 to 300 degrees Celsius, which is typically coincident with the most onset of seismicity. In this context, Pythias oasis stands out for not only being a water-dominated system, but also for potentially informing on reactions occurring within the seismogenic zone in the central CST. CSC set. Yeah, that's an amazing picture. Fledermaus midwater. The warm water-dominated vent at Pythias Oasis, the high volume 12 degrees of pressure, to a 5 centimeter diameter vent located. Yeah, this is very interesting. So let me show you just one, like since this is 5 centimeters in diameter. And this is 20. And this is my mud volcano in the yard. And you can see there's like stuff oozing out there. And there's different colors, as you can see here. There's probably have been bubbles coming out, I don't know. But this region is a bit darker than the surroundings. And it has also experienced some kind of an overflow on that side. These are remnants of the ice crystals. And it's not that well visible. The thing is here. That's the... No, I missed. This is the caldera, so to say. And it's on top of this very small mountain, maybe 15 centimeters. It has been, maybe even more, I don't know, it's hard to say. But this used to be flat, and now it's going up and down. And on top of that, we have that thing. So there must be somewhere down there must be warmer than elsewhere. Otherwise, there couldn't be liquid stuff pouring out of the ground. Yeah. I didn't see that one coming, to have this kind of mini mud volcano appearing in the yard. And since clay has been very fascinating for some time. What? Someone provided me with a mud volcano. Yeah, what to do? I find it very interesting. This is how I try to emphasize that it's really rising up there, and on top of the small mountain there is something coming out. Liquid water. And there was some clouds today as well. This is a panorama picture. So these were totally straight, those clouds. And now they make a bend. And this is a little bit later once again. And I think I will end it with this. That's the enhanced version of the picture. Very nice. We had the whole day halo, but it doesn't seem to be anymore. Yeah, mud volcanoes, clouds, and subsurface mountain water. Thank you.